In math, sometimes the smallest things can cause the biggest headaches. And today, we're talking about a tiny two-letter word that almost everyone gets taught a simple rule for. The word is of, and we're about to bust a major myth about what it really means. So, get this. A study asked a bunch of future elementary school teachers why a problem like 15% of 200 means you have to multiply. And this was their answer, overwhelmingly. It just goes to show how deep this idea runs. Of means times. But is it really that simple? And let's be honest, this is the rule most of us learned, right? Of just means times. It's a neat little shortcut that seems to work, especially when you're starting out with fractions and percentages. But as we're about to find out, relying on this simple rule can actually prevent a much deeper understanding of what's going on. Okay, so before we completely dismantle this idea, let's give it some credit. There's a reason this rule exists. And to be fair, in certain situations, it works perfectly. So let's dive into where this of means times idea comes from and why it feels so right. I mean, think about it. If I say 2/3 of 60 or 15% of 200, you multiply, and bam, you get the right answer. Every time it works, it reinforces that rule in our minds. But what's really happening under the hood, mathematically speaking? And this is the big reveal, the key idea right here. Of doesn't actually mean multiply. What of really signals in this case is that we're taking a piece of a whole. We are scaling a quantity. And yeah, multiplication just happens to be the tool we grab to get that job done. This visual really helps drive the point home. When you're finding a percentage of something, it's all about proportionality. You're just finding a part that matches up with a whole. Multiplication is the how, not the what. It's the procedure we use to figure out that relationship. All right, so far so good. The rule seems pretty solid in its little comfort zone. But what happens when we step outside that world of simple fractions and percents? Well, this is where that trusty little rule doesn't just bend, it shatters. Okay, check this out. On the left, 15% of 200. The old rule works like a charm. But now, look at the right. 3 out of 5 students. That sentence also uses the word of. But if we just blindly follow our rule and multiply 3 times 5, we get 15. What on earth is 15 supposed to mean here? It's complete gibberish. The rule has officially failed us. So what's going on? In this context, out of has nothing to do with scaling a number. It's all about a relationship, a comparison between a part and a whole. It's telling us to think of a ratio, which we'd write as the fraction 3/5. It's a totally different job for the word of. Okay, let's take this to the next level and jump into some algebra. On the left, 1/2 of 10, easy peasy. But on the right, f is a function of x. Now, if you stick with that old of means times rule here, you get f times x. And that's a huge mistake. It basically makes understanding most of algebra impossible right from the start. Right, so what does of mean in function of x? It means dependence. It's signaling a relationship. It's telling you that whatever value f has is completely determined by the value you plug in for x. Of is a connector word here, not a math command. And if you thought that was a big leap, let's push it even further. We've got f of g of x. This is something called function composition. And I'll tell you right now, if you try to read this as f times g times x, you're not just going to get the wrong answer, you're going to miss one of the most powerful ideas in all of math. So what's the deal here? In this case, of is telling you there's a sequence, a chain of events. It means apply this to the result of that. You figure out g of x first, take that answer, and then plug that result into f. It's all about layering processes. Let's look at one more. On one hand, we can find a fraction times a number, like 1/3 of 9. But what about the inverse of 3? Does that mean we multiply something? No way. Actually, it's about doing the complete opposite. See, here, of is part of a team, inverse of. And that whole phrase means the thing that undoes. The multiplicative inverse of 3 is the number that reverses or undoes multiplying by 3. And that number is 1/3. So here, of is pointing us toward reversal, not multiplication. Okay, so we've seen the of means times rule work just fine, and we've seen it fail spectacularly in a whole bunch of different situations. So what gives? What's the real story here? What's the better, more accurate way to think about this powerful little word? And this, right here, is the most important thing to take away from all this. Of is not an operation. It's not a verb telling you to do something. It's more like a signpost. It tells you two things are connected, and it's our job to be detectives and figure out how they're connected. Are we scaling something? Is it about dependence? Or maybe undoing something?
I mean, just look at this table. It's amazing. That one single word of can signal taking a piece of a number, or a ratio, or dependence, or composition, or reversal, or even just a property of an object, like the slope of a line. The context is literally everything.
And that really brings us to the ultimate point. The habit we should be building isn't of means times. The real powerful habit is asking ourselves, okay, what does of mean in this specific situation? That question is the key. That's what unlocks real understanding in math. And that really makes you think, doesn't it? This whole of means times thing is just one example of a shortcut that can actually end up being a roadblock. It really makes you wonder, what other little rules, what other so-called tricks did we all learn in school that are actually getting in the way of seeing the beautiful, connected, bigger picture of math?